Okay, let's do some uniform motion problems. These are unequal distances. So let's just review real quick the types of problems that we've done so far. So far we've had a distance. Here's a distance. We had guy 1 went this distance, he would be distance 1. And then we had guy 2 went this distance, and he would be distance 2. Or we had guy 1 went this way, and then guy 1 went the same distance back. And these are the easiest types of problems, and that's where you have distance 1 equals distance 2. Now the last class we did problems where we had, there's 3 different types, but they're all the same where you add the 2 distances together. Either you start at the same place, and one guy goes this way, that's distance 1, and the other guy goes this way, distance 2. Or you might start at a point and crash. Guy 1 goes this way, guy 1 heads towards him, and they crash. That's still distance 1 plus distance 2 equals a given distance. Or you could have guy 1 like walk this far, that distance, and then maybe he runs this far, and that's distance 2. So these problems are distance 1 plus distance 2 equals a total distance, which we call n, of n. Now this week we're going to do a new type of problem, but before we do that, I want to give you a little help on your test. This problem, this is a test practice review problem, so it's like the type on your test. Not exactly, but it's similar. So let's give this one a try. Train starts from Peoria at 2 p.m., heads for Reedley, 750 miles away, kilometers away. At the same time, a train leaves Reedley and heads for Peoria at 85 kilometers. If the trains meet, note they don't crash, they meet at 5 p.m., what is the rate of the first train? So this is the type of problem like this one right here in the middle. They're starting from different sides and they're meeting in the middle. So here's our 2 sides we're starting from. This first one, he's going to start from Peoria, so we'll call that distance Peoria. And this one is from Reedley, so we'll call this distance Reedley. This one starts at 2 p.m. and then it says at the same time a train leaves Reedley, so that would also be 2 p.m. and they meet at 5 p.m. It says that they're 750 kilometers away, so this is 750 kilometers, that's our n distance. And now we're going to set up our equations. We have distance Peoria plus distance Reedley equals 750. Now this is the type you're going to have on your test. I'm not sure if they meet in the middle or if they go opposite directions, or yeah, it's either one of these two. So your equation is going to be distance 1 plus distance 2 equals whatever big distance they give us. So keep that in mind for the test. Alright, we do our little translation. Distance equals rate times time. Reedley times Reedley equals 750. So that's equation number 1. We have 4 unknowns, so we need 4 equations. This is one of them. The time, if they're going from 2 to 5, both of their times, the time Reedley equals 3, and the time Peoria equals 3. And then we just need to know the rate. It says a train leaves Reedley, heads for Peoria, so the rate of Reedley is 85. This was pretty easy because we didn't have to come up with any complicated equations for our final equation. All we do is we substitute these in and we should get an answer. So RP we don't have, so we're going to leave that variable in. TP is 3. So it's 3 RP. Rate Reedley is 85. Time Reedley is 3, and that equals 750. So we get 3 rate Peoria plus, I need to get a calculator out, be patient here for a second. Calculator, okay, it would be 85 times 3, so we get 255 equals 750, and then finally 3 rate Peoria. I'm going to subtract 255 from both sides and get 495. Now I'm going to divide both sides by 3. rate Peoria equals 165 kilometers per hour. So that's the type of problem on the test. So hopefully that helps you. Let's do our new kind of problems. Try not to make this video 20 minutes, Rosie, but it's pretty hard because there's 3 problems we have to do here. We did this one in class, but by the time you do these, I'm sure you're not going to remember these. Let's just try it. At 8 p.m., Achilles left camp and headed south at 20 kilometers per hour. At 10 p.m., Patroclus headed south from the same camp. If Patroclus was 50 kilometers ahead by 3 a.m., what was his speed? I think this is one of the more complicated problems of this type. This type is, you have a distance, you have one person going the whole way across, so that would be, the person going the whole way across would be Patroclus, because he was 50 kilometers ahead by 3 a.m. So this would be the distance Patroclus. The Achilles left the camp, and he wasn't quite as fast, because Patroclus got ahead by 50 kilometers. So this would be the distance Achilles. These problems are always in the form, you have a distance 1 guy, and then you have a distance 2 guy, plus n. So the equation for these are going to be distance 1 is equal to distance 2 plus n. And you can see that this is distance 1, and distance 2 plus n is the same distance. You have to add the n onto it. So I'm going to write this equation. It would be distance Patroclus equals distance Achilles plus 50. Translate. Rate Patroclus times Patroclus equals rate Achilles times Achilles plus 50. We need to get our other 3 equations. Let's see. Achilles left at 8 a.m. Left camp and headed 20 miles per hour. So we know Achilles' rate. The rate Achilles is 20 kilometers per hour. At 10 p.m., Patroclus headed south. So Patroclus is leaving at 10. 2 hours later, that's a fast guy. If Patroclus was 50 kilometers ahead by 3 a.m., so this is 3 a.m. right here. They both ran until 3 a.m. So this guy went from 10 to 3, so that would be 5 hours. So the time Patroclus is 5, and the time Achilles, he started at 8 and didn't finish till, when this guy was 3 a.m., 50 kilometers ahead, so that would be 7 hours. So 8, 2 more than this one. Now we have everything we need, we just plug it in. Rate Patroclus, we don't know that, that's what we have to find out. Time Patroclus was 5. Always put the number before the variable. Rate Patroclus equals rate Achilles, which is 20. Time Achilles is 7 plus 50. So we get 5. Rate of Patroclus equals 140 plus 50. 5 rate of Patroclus equals 190. Divide both sides by 5, and we should come up with an answer of 38 kilometers per hour. And that's what they wanted to know. They wanted to know the rate of Patroclus was 38 kilometers per hour. The other guy was 20 kilometers per hour. And he passed them. Okay, let's try another one. I think that was one of the hardest ones. Whoops, I didn't make my box big enough to catch this whole problem. I'll just have to slide it back and forth. Rachel has a 15-kilometer head start on Charlene. How long will it take Charlene to catch Rachel if Rachel travels 70 kilometers per hour and Charlene travels 100 kilometers per hour? You can already see this has some easiness to it because it tells you the rates of both of those. So that's nice. And it also tells you Rachel's speed. That's nice too. Okay, here we go. We have our problem. Rachel has a 15-kilometer head start. So this time, she's starting 15 miles ahead of Charlene. So this is the distance of Rachel. She's starting out here. Charlene is starting back there. She doesn't get the head start, so this is the distance of Charlene. And they want to know when they're going to catch each other. When Charlene's going to catch Rachel. Obviously Charlene's the faster runner. This would be the place where they catch each other, or Charlene catches Rachel. So here we write our equation. We would say 15 plus the distance of Rachel equals the distance of Charlene. 15 rate Rachel times Rachel equals rate Charlene times Charlene. We have all this information. We have the rate of Rachel is 70. Let's see, what else? Charlene, rate of Charlene, we have that one too. You can't see it, but it's 100. And do we have any times going on here? Does it say how long? The times are the same because they both start at the same time. So, how long will it take? Well, the times are the same. Whenever she catches her, it'll be at the same time. So time Charlene equals the time of Rachel. I guess that's kind of tricky. Figure out the time. They don't tell you anything about the time, so if they don't tell you anything, then they're probably equal. Now we just substitute these in. So we get 15. We'll just keep the R's in there for the time. So rate Rachel is 70, time Rachel. And you can actually drop the subscript if the times are the same. Let's try that for this one. So that means the times are equal. So you can just say the times are equal. You don't even need subscripts. Equals rate Charlene, which is 100, times Charlene would just be T. Subtract, you get 15 equals 30 T. I subtracted 70 from 100. Now I'm going to divide both sides by 30. Time for both of them is going to be 1/2 an hour. So that's how you do that problem. That was fun. Okay, one more. Hold on, I don't even know how long this is. I don't have a timer on my recorder thing. Okay, Harry and Janet jog around a circular track that is 210 meters long. Janet's rate, let's just write that in. Rate Janet is 230 kilometers per minute, while Harry's rate, I like when they give us all this, is 200 kilometers per hour. Meters per minute. Sorry, minutes. In how many minutes will Jeanette be a full lap ahead? Well, again, our times are the same. Time Janet equals time Harry, because by the time they're going to start at the same time, but one person's going to go around while the other person's still doing the first lap. Now this doesn't help us to do the circular thing, so we're going to stretch it out. So the first guy is going to get a whole lap ahead, is going to go the whole way. So the circular track is 210 meters long. How many minutes will it be for him to get a full lap ahead? So it's good to straighten it out. So a full lap would be, hold on a second, just straightening it out, the map, so this one would go not the whole way, there would be 210 left, because they had a full lap to go. I should have did that equally. So Harry and Janet's rest rate, Harry's is only, so this is the rate, oops, this is the distance of Janet, I can't say that name either. And this is the distance of Harry. Harry's a slower guy. So this guy gets a full lap ahead, which is an extra 210. So we have to add this on, because when this guy gets a whole lap ahead, the time will be done. So their times are equal. So we get distance Harry plus 210 equals the distance of Janet. We just substitute, we do our rate Harry, time Harry, plus 210 equals rate Janet, time Janet. And we just substitute 200. Times are the same, so just leave out the subscripts. That makes it a lot easier, I think. Rate Janet is 230 T. Subtract 200 from both sides, so we get 210 equals, that would be 30 T. And so we get t, if we divide both sides by 30, the time equals 77 minutes. So we're going 7 times. And I think that's what they're asking for. And how many minutes will Janet be a full lap ahead? Well, in 7 minutes, this guy will be here, this guy will be here. So their times are the same. And he went full track ahead. Alright, these are kind of complicated, but do your best. We'll do them again next year. And hopefully you'll at least be able to get the equal distance problems down well this year. Alright, that's it for lesson 99.